hydraulics lab in the Department of Biological Systems Engineering. This is used to support our teaching activities. We have several classes that do hands-on laboratory activities right here, and that hands-on learning is a very important part of our educational program. We do labs ranging from pipeline flow, pumping labs, to water quality labs, looking at soil erosion and nutrients in runoff. So one of the real-world applications is center pivot irrigation systems. Nebraska has more irrigated acres than any other state, and the things we do in here directly correlate to the pumping plants for irrigation systems, as well as friction loss and managing those systems efficiently. We are operating right at the intersection between food security and water security. Welcome to the Hydraulics Laboratory in the Department of Biological Systems Engineering. The first thing I would like to show is the pumping stations that we have. One of the things we enjoy doing is helping students appreciate where their water comes from. Most people have a hard time visualizing what a pump and a well looks like underground. And so we have a cutout from our industry partners here that shows the impellers that spin quickly to pump the water up to the ground surface, and from there it can be used either for a municipal water supply or for an irrigation system. Even better than the display, we have several pumps of our own behind me, and we also have a large tank of water that holds over 10,000 gallons of water that we can use to pump throughout the lab. If you just take a quick look, we can pump from the pumps here through a piping system. We have various ways of measuring water flow rates. And the water circulates. We can do various things with it throughout the lab, and it returns under the floor to the reservoir where it started. This is a chemigation unit that we use in one of our labs. Chemigation is significant for a couple of reasons, both for our irrigation and our water resources. From an agronomic perspective, chemigation, which applies chemical through an irrigation system, is a very efficient way of delivering chemicals to the crop, especially fertilizer, but it can also be used for pesticides as well. Since the irrigation system is already in the field, then extra passes of machinery from a sprayer is not necessary. It also allows us to deliver the nutrients at just the time that the crop needs them. So this is very helpful from a fertilizer management perspective. Those fertilizers are essential for producing high yields, but we want to minimize any excess fertilizers that might harm our surface water quality. All right, this is another part of our water lab facility. In contrast to the water quantity that was the focus in the hydraulics lab, here we're more focused on water quality. We can test soil samples, soil properties, and also looking at how contaminants move through those soils. We also have some more chemistry type functionality in this part of the lab. One of the things we're really interested in is water quality. If we think about watersheds on a large scale, looking at the impacts of agriculture on the streams and the reservoirs, water quality is a really important component of that. We're interested in measuring things like nitrogen and phosphorus in the water, as well as sediments, pesticides, and other contaminants that are becoming more important each year. Yeah, the lab is really unique among our sister institutions across the country. It's really an asset because of the hands-on opportunities it provides students. Most places don't have this type of facility, and we can really see the light go on in the learning experience when they can run tests with different pipe sizes, see the friction loss, measure it, and get a feel for how that will impact systems in real life.